Hello everyone, welcome to 8.1, Simplify Rational Expressions. We start off with chapter 8 here, and we're going to start it simple with rational expressions. The concept of rational expressions is something that you're familiar with, but you've not heard this word before. Okay, so let's start by kind of understanding what rational stands for. So I'll say rational. What do you think is the word hidden in rational? The word in rational is ratio, right? See ratio? So that's your big clue. Okay, rational means your setup is always going to look like a ratio. A ratio means fractions. Okay. Fraction obviously means a numerator and a denominator. For the sake of denominator, for the sake of the class, we're going to just call this NR and DR. Okay, numerator and denominator. Well, if it's fractions, then it's simply two numbers, one on top and one in the bottom. But we didn't call it fractions, we're calling it rational. So what does this fraction contain? Well, this fraction is not a number over a number. Instead, it's a polynomial over another polynomial. Okay? And we saw in chapter 7, 6.2, about polynomials. Polynomial is a string of terms that are separated by a plus or a minus. And each term is a combination of numbers and letters, letters raised to powers. Right? That's the idea of polynomials. And all along, we've learned how to handle polynomials, how to factorize polynomials. So if it's just depending on the leading coefficient, you decide if it's BC method, AC method, and that's how you choose to break them into factors. And as always, we will look for GCF to get this going, right? So now we have a clearer understanding of polynomials. Now we can handle rationals because it's now polynomial over polynomial. The only difference is your polynomials are happening in a fractional setup, in a rational or ratio setup, and therefore we're going to learn certain things of simplifying them before we actually move into adding and subtracting and so on. Okay. All right. So we have two objectives here. We're going to find values for which the rational expression is undefined, and we're going to evaluate rational expressions. Okay, two things here. Let's talk about undefined. Okay. When do we use this language in math? Okay. Whenever you have to end up dividing by a zero, the expression becomes undefined. Okay. So I'll just say any number over zero is undefined. You really don't want to forget this lesson. Okay. Anything over zero is undefined. When I say anything, of course, it shouldn't be a zero. Okay, 0 over 0 is bad. Okay, so we don't have to have a specific number. It could be any number on the top, but we just want to avoid 0 being on the top. Okay. What about 0 over any number? The answer is it is 0. Okay, any number over 0 is undefined. 0 over any number is 0. Again, think of this as fraction, the example of seeing this as a setup in fraction. When you have 0 in the denominator, anything in the denominator means the whole thing, right? Part over whole is your fraction. Part over whole. Let me write it here. So you have the whole thing happening in the denominator. And when you have 0 in the denominator, we're saying all that we have in the denominator is 0. And any number on the top tells me how I'm going to share that 0. Can you already see that it's kind of absurd? You have nothing, but here you are trying to share it, right? So that's why it becomes undefined. You're starting to share something that doesn't exist, okay? Something that is not there. On the other hand, 0 over any number, let's look at that. So this any number, let's say 5, your any number, 5, is your denominator, meaning that's all you have. So you have 5, let's say 5 chocolates. And 0 on the top tells me how you're going to share it. So 0 tells me that you have 5 chocolates, but you're not going to share with anyone any part, right? You're not going to share any part of the 5. That tells me that you're not really going to share. You're going to keep all that you have. Therefore, the answer is 0. Okay, so this is a quick way to think about this logically and see how this would make sense to call it undefined and where does it become zero. Okay, so just to put it as a rule, any number over zero is undefined, zero over any number is zero. All right, let's get into the lesson. Determine the values for which the rational expression is undefined. So there's a reason why I was talking about undefined. This is when the denominator becomes zero, right? When your denominator is zero, the expression is undefined. So that's what we're going to focus on in each part. Let's take part A, 9y over x. The denominator here is x. We're only focusing on the denominator because only that will make the expression go undefined. So denominator. Okay. So to find the values that make the expression undefined, we must set the denominator dr to 0. Okay. It's always the case. Okay. This means your denominator is an x, set it to 0, and you will solve for x. Okay, now this is a trivial problem. You already solved for x by simply setting it to 0 because you didn't have anything else to reduce the x to. Like you didn't have to isolate x, you didn't have to throw numbers to the right and so on, right? So here in this case, this itself is your answer. In other words, you're saying, well, when x takes the value 0, the expression becomes undefined. Okay, so we have determined the values that will make it undefined. So actually 0 is not a good, when x takes the value 0, it's not a good thing. So we're trying to see what are those restrictions, what should I avoid? So if I have a question A, I should avoid 0 for x because I know that that's going to make it undefined. Okay? So even though I say x equals 0, we don't want x to be 0, but we're identifying what will make it become undefined. And so I'm saying, well, x equals 0 will make it undefined. Okay. Let's go to B. B has 4b minus 3 over 2b plus 5. Okay. Once again, the focus is on the denominator. Okay. So we set the denominator to 0, which implies the 2b plus 5 is now set to 0. Okay. Go ahead and solve for b because b is your missing variable. Okay. At this point, we are actually recalling all that we learned in chapter 2. Chapter 2 was solving equations. So you're just going to solve the equation here by collecting all your variables on one side and collecting all the constants on the other side. That'll be 2b equals -5. One more step. And that'll be to divide both sides by 2. Okay, so b equals -5 over 2. What this tells us again is, if b takes the value -5 over 2, your expression in question B will become undefined. Okay, that's what this means. I boxed this as an answer because if you go back to the question says determine the values for which the expression is undefined. And we did determine that the value b equals -5. Let me make the negative a little sharper. B equals -5 over 2 is indeed the value that makes it undefined. Okay. Let's go to part C. Part C was x plus 4 over x squared plus 5x plus 6. X squared plus 5x plus 6. Again, your denominator is of concern. So denominator equals 0 implies you take the denominator and set it to 0. Okay? Right there you got a polynomial because remember, rational is polynomial over polynomial. So you are setting the denominator polynomial to 0, and we know how to handle polynomials because we have learned about the AC method and the BC method, pulling out the GCF and all that. So let's put that into use here. As always, step 1 is to identify and factor out any GCF. You look at the terms, there are no GCFs, no common GCF here, so we do not factor out. There's no step 1. Step 2 is to look at the leading coefficient. The leading coefficient is 1. Therefore, we're going to use the BC method. Okay. You remember, BC method is the X method or the diamond method. So you're looking for 2 numbers, right? Let me write what B is. B is 5. C is 6. Looking for 2 numbers whose sum is 5 and whose product is 6. Okay, based on our extensive practice in the previous chapter, you can already identify those 2 numbers, right? That's going to be 6 and 1, but that will multiply to give you a 6. But you want them to add up to 5. So what do you think could be the best option? So let me list it out here. You're going to only go for positive numbers. So 1 and 6 will give you a product of 6, but it doesn't add up to a 5. So we're going to choose the other option, 2 and 3. 2 times 3 is 6, but 2 plus 3 is 5. So you have that. Just like that, you can enter your answers because it is BC method. If it's AC method, you have more work to do. And again, if you are a little rusty already, shouldn't be, you always can go back and look at the videos from the AC method and refresh your knowledge. Okay, if you recall again, we looked at zero factor property in chapter 7, which means if you had factors on one side of the equation and 0 on the other side, you can set each factor to 0. So that's the first factor. I set it to 0. Or let me write this again. X plus 3 equals 0. I put here somewhere saying it's the zero factor property. Okay, it's because it's an equation, you have that one extra step. If you didn't have equals 0, you will simply put them as factors and stop there, right? But here that's an equation, you're going to go further and solve it. So let's go ahead and solve them individually. X equals -2 or -3 minus 3. X equals -3. So you have come up with 2 answers. I'll just write it here. These are the 2 possible numbers that will make the denominator 0. Okay, so we technically do not want these 2 numbers for X because that will make it undefined. But it's good to identify it so we know what will make it undefined. And that's how you answer this part. Next, we move to evaluating rational expressions. Okay, evaluate. Let's again recall, evaluate. What's the word hidden in evaluate? Value, right? That means you have to find the value. That's what you're supposed to do, okay? To find the value, mostly we use substitution method. Okay? When you substitute for the given variables, then you are able to find the value, right? That's it. So evaluate, in this case, it's a rational expression, but we've always done evaluate, starting from chapter 2. So just remember the clue in the word itself to guide you on what to do. So you have the same expression, 2x plus 3 over 3x minus 5 for all the 3 parts. But in each part, they're telling us what x will be. So they're telling us in part A that x should be substituted as 0. So when I have to substitute for something, I draw a shell so that I will plug it in there. So wherever x occurs, I open shells so that I could substitute for 0 as given in this part. So that's going to be 2 times 0. Remember, PEMDAS works always, but in a fraction, they happen simultaneously, right? Up and down. So I'm going to work on the top, the numerator first. So 2 times 0 is 0. 3 times 0 is 0. 0 minus 5. This simply reduces to 3 over -5. You know how we usually like to write with a negative in the middle? In the middle or on the top? But I think with your online exercises, putting them in the middle is the way they want you to do. So that's your expression that's evaluated. So your expression is evaluated to give a number, right? We found the value. This is the value when x equals 0. Okay. We're going to find similarly for parts B and C. So at this point, you could race ahead and wait for me to catch up with you. Okay, x equals 2. Let's write that down. Same expression. X equals 2. Okay, once again, let's write this with shells for x. And drop in the 2 wherever x occurs. Okay, PEMDAS again, so multiplication actually happens first. 2 times 2 is 4, 4 plus 3, 3 times 2 is 6, 6 minus 5. Looks like a division, let me fix that. Okay, so that is 4 plus 3 is 7, 6 minus 5 is 1. So you want to always simplify this, so don't leave it as 7 over 1. This is simply a 7. Okay. When you're kind of finishing off the answer, simplifying, I tend to go horizontal. But remember, you always write your steps one below the other. Okay? It's only when you're simplifying, you're just one step away, I tend to write it horizontally. Okay? All right, and what was the third one? Third one was when x is negative 3. Let's write that out. Part C is 2x plus 3 over 3x minus 5 when x is negative 3. And you will notice that here the shell really comes in handy because we're going to now plug in a negative number. Okay, so 2 shell plus 3, 3 shell minus 5. Let's plug in negative 3 and negative 3. See how the negative is carefully protected? So when you do multiply them out, 2 times negative 3, that is going to be negative 6 plus 3 over 3 times negative 3 is negative 9 minus 5. So that's negative 6 plus 3, which is negative 3 over negative 9 minus 5, you have to add the 2. So that's going to be a 14 with a negative common sign out. Again, negative over a negative. You have to simplify the signs. 3 over 14 cannot be simplified, but you can definitely get rid of the minus because minus over minus is plus. So 3 over 14 will be your final answer upon evaluating. So that's for part C. Let's focus on the last piece here. X squared plus 8x plus 7 over x squared minus 4, right? So x squared plus 8x plus 4 with x getting a shell everywhere. That's a minus 4. And drop in 0 for all your x values. That's fun because the numerator just becomes 7 and the denominator is simply a negative 4 because all those zeros go away. That just gives us negative 7 over 4. We'll box that. What about B? So at this point, let's just try to put the shells right away. And for part B, you have to plug in 2 for x. Okay, PEMDAS again. Okay, so parentheses, exponents, PEMDA. So 2 squared for 16 plus 7. 2 times 2. 2 squared is 4 minus 4. Okay, so that's going to be 27 over 4 minus 4 is 0. Ooh, we have something over 0. Think about it. Is that a good thing? Okay, think of 0 in the denominator. 0 in the denominator indicates that you your whole is 0 and you're trying to share it with 27. There's nothing there, but you're sharing with 27. Is that making sense? So obviously your answer here is undefined. Okay. And let's box that. Again, you might see a symbol for undefined, and that symbol will be like a circle with a line through it. It's called the phi, P-H-I. Okay. So again, for online answers, you might be asked to select an option that says undefined, or select an option that has that symbol, or sometimes enter that symbol as your answer. And you'll see a math palette, like a little table that will help you to insert these symbols. Okay. Okay. The last part. That will be a -1 in the place of x, -1. Again, see how well the shell works. So -1 squared is nothing but -1 times -1, which is +1. And then +8 times -1 is -8. You have to tread carefully here. -1 squared is -1 times -1, which is +1 minus 4. So then we have 1 minus 8, which is -7. -7 plus 7 is a 0 over -3. Think about this, 0 over -3. Forget about the negative for the moment, right? Let's just think about the 3 in the denominator. So 3 is a whole, and you're trying to share 0 out of that 3. Okay, it's not, it does make sense that you don't want to share, but it's not impossible, right? You can keep it to yourself too. So this is not an undefined situation. It's a situation where the answer is simply a 0. The answer reduces to a 0. Okay, and that's how we do this section. Again, remember, you're looking for looking for values that can make the expression undefined by setting the denominator to 0. And you also have these kind of problems where you evaluate by plugging in the x values to figure out what number it reduces to. And we always reduce to its lowest terms, especially in these two cases where you ended up with undefined situation and a 0 situation. I hope that helps. I'll see you in the next video.